So we're continuing just our work through solving equations. And last time you recall, we solved equations with variables that were only on one side. Now we're going to solve equations with variables on both sides. The good thing is it's the exact same process as solving with variables on just one side. So here's an example. Our problems looked like this. It was like 3x plus 6x plus 5 equals 15. Now our problems are going to look like this. 3x plus 6x plus 5 equals 15 minus 2x. So this time there's letters on both sides of the equation, but it doesn't change the way we work the problem. So we're going to go through the steps again just to review. And again, as I go through the steps like I did in class, I'm also going to work this problem down here below. Problem 1. So our very first step is to draw the line through the equal sign, which designates our sides. So I'm going to go down here to problem 1. I'm going to do that. I'm going to draw my line through the equal sign. And then for step 2, we need to simplify each side. Remember, that is our combining like terms. Okay, so we're going to simplify each side, which means we're going to combine our like terms. Well, when I look at this, if I look at my left side here, the 12 and the negative 3x aren't like terms, so I can't do anything there. The negative 6x doesn't have anything with it, so step 2 is not going to apply to this problem. So let's look at step 3. So step 3 is to label our sides. Remember, one side is the variable, and the other side is everything else, which we abbreviate as EE. That just gives us an idea of what we need to put where. So this time I'm going to label my left side as my variable, which is my x's, and my right side is EE, which again stands for everything else. My third step is to start moving my terms. So we're going to start moving our terms by adding or subtracting. What we're doing at this point is when we're moving our terms, we're getting things on the right side, on the correct side. Let me use that word. We're getting things on the correct side. So remember, everything with a variable needs to be on one side, and everything else needs to be on the other. So if I look at my problem that I have here, what this means is that if it's on the left side, it should have an x with it. So two things are out of place then. This 12 is out of place because it doesn't have an x, so the 12 needs to move over to the right. The negative 6x is also out of place because it has an x with it, so we're going to have to move it to the left. So I'm going to start by getting rid of my 12. To get rid of my 12, remember our 12 is positive, so I'm going to minus 12 from both sides. So on the left, my 12s are going to cancel, and I'm left with negative 3x equals, okay, over here on the right, this negative 6x minus 12, I can't combine those because one has an x and one doesn't, so I'm just going to have to rewrite it. Negative 6x minus 12. So also, I know that everything that has an x should be over here because this side is my x side. So I'm going to get rid of this minus 6x here. It needs to move over, and I'm going to do that by adding 6x. Remember, whatever you do to one side of the equation, you have to do to the other. So negative 3x plus 6x is 3x equals, my negative 6 and positive 6x are going to cancel, and I'm left with negative 12. So my last and final step is once the variable is isolated, remember isolated means it's by itself. Once the variable is isolated, you must multiply or divide by the coefficient. You must multiply or divide by the coefficient. So my coefficient here is 3. Remember, whenever I have a number and a letter attached, they are multiplied together. So to undo multiplication, I'm going to divide both sides by 3. And again, the rule says whatever I do to one side, I must do to the other. So I'm left with x equals, well, negative 12 divided by 3 is negative 4. So this should be my answer. Well, I'm going to check my solution here. To check my solution, that means I'm going to take my original problem, 12 minus 3x equals negative 6. And instead of x, I'm going to plug in negative 4. I want to see if it's right. And I'm going to plug it in every time I see an x. So I'm going to rewrite this as 12 minus 3, parentheses, negative 4. Remember, if you take a letter out and put a number in its place, you put that number in parentheses. So equals negative 6 times negative 4. What I've got to figure out, does the left side equal the right side? That's the question we're asking ourselves. So over here, this negative 3 times negative 4 becomes 12 plus 12 because negative 3 times negative 4 is positive 12. Equals negative 6 times negative 4 is positive 24. And if I simplify this right side here, because I just have 12 plus 12, 12 plus 12 is going to give me 24. And my right side was also 24. So since the left side and the right side were both 24, that told us that yes, this was a solution, so we were correct. So I have another problem. I'm going to do problem 3, and I'm going to go through the exact same process. So the first thing I'm always going to do is I'm going to draw my line. So my second step is to simplify my equation. So if I cover up my right side just to kind of help us out, let me look at the left side. Well, the left side says 7 minus 5z. I can't combine anything together, so that doesn't help me. So I'm going to look at the right side. I have 17 plus 5z. Again, I can't combine anything together, so this is as simple as it will go. Which means I can move on to my third step, which is to label my sides. So when I label my sides, I'm labeling one side as my z's, because that's my letter, and one side as EE, which stands for everything else. So then I can start figuring out what needs to move. Well, if everything on the left side should have a z, then that tells me 7 is out of place. So to get rid of my 7, I'm going to minus 7 from both sides. Now when I minus 7 from this right side over here, I have to think about what can I minus 7 from? Can I minus 7 from the 17, or can I minus 7 from the 5z? Well, since minus 7 and 17 are like terms, that means I can put those two together, so I'm going to write them on top of each other. So 7 minus 7 is going to cancel. I get negative 5z equals 10 plus 5z. Well, so I need everything over here just needs to have numbers, basically. Everything on this left side should have a z. That tells me my plus 5z is out of place. So I'm going to get rid of that by minusing 5z from both sides. So negative 5z minus 5z is negative 10z equals 10. And my third and final step is to solve. And to solve, I have to get rid of this negative 10 here. Remember, negative 10 and z are multiplied, so to get rid of it, I'm going to divide both sides by negative 10. And 10 divided by negative 10, be very careful. 10 divided by negative 10 here is equal to negative 1. A lot of people think that it's equal to 0 because they're trying to subtract, but 10 divided by negative 10 is equal to negative 1. So we're going to do problem 4. And again, problem 4 is another solving, I'm sorry. So I'm going to draw my line down the middle. That's always my very first step that I'm going to do. And then for my second step, I need to simplify each side. So I'm going to cover up the right side first. And I want to look at the left side to see if I can combine anything together. Well, notice you have a 6x and you have a minus 10x. Well, they're like terms, so I can put them together. So that's going to give me, for my simplified form of my left side, 8 minus 4x equals, then I'm going to cover up the right side, sorry, the left side, and I have 16 minus 8x. I can't do anything here because this doesn't have an x and this does, so I cannot combine those together, so I'm just going to write it, 16 minus 8x. My third step is to label my sides. So recall, one side is your x's, and one side is going to be EE, which is going to stand for everything else. So that means if it has an x, it needs to be on the left. If it doesn't have an x, it needs to be on the right. So there's two things that need to move. The first of those things that needs to move is this plus 8. To get rid of a plus 8, I'm going to minus 8. If I do something to one side, I have to do it to the other. So 8 minus 8, those are going to cancel. I'm left with negative 4x equals 16 minus 8 is 8 minus 8x. Well, recall, everything with an x should be over here on the left. That tells me my minus 8x needs to move. To get rid of my minus 8x, I'm going to plus 8x to both sides. Negative 4x plus 8x is positive 4x equals 8. Remember, when you have a letter and a number that are attached, they are multiplied. And to undo multiplication, we're going to divide. So we're going to divide both sides by 4. So we end up with x equals 8 divided by 4. Be very careful. We're not subtracting. We are dividing. 8 divided by 4 is 2. So our answer is 2. It is important to note that sometimes when we solve, we get something weird. So we're going to do problems 5 and 6, and then we're going to talk about what these things mean. So starting with problem 5, first thing I'm going to do is I'm going to draw my line down the equal sign. And then I need to simplify each side. So I'm going to draw a box so I can cover up my sides. So I'm going to cover up the right side, and I'm going to look at my left. And notice I have 5x and minus 2x, and these are like terms. So 5x minus 2x is going to give me 3x. Minus 6, because I can't do anything with that 6, equals, then I'm going to move my box and look at just the right side. Oh, over here I need to distribute because I have parentheses. 3 times x is 3x. 3 times negative 2 is negative 6. Now some of you are already looking at this and thinking, oh, there's something interesting here. We're just going to keep going for now. So our next step says that we're supposed to label our sides. So our x's go on one side and everything else goes on the other. And our third step is to start moving things around, things that are in the wrong place. Well, if everything on the left should have an x, then I need to move my minus 6. So I'm going to do that by adding 6 to both sides. So now I have 3x equals 3x. Well, I'm supposed to have everything with an x needs to be over here on the left, which means this 3x on the right needs to move. So I'm going to minus 3x from both sides. Well, they cancel, and I get 0, and they cancel again, and I get 0. So that's weird, because everything canceled. So we're going to talk about why in a second. So let's look at the next problem and see what happens there. So now onto problem 6. I'm going to draw my line. I'm going to cover up my sides and see if I need to get rid of anything or combine anything. So I have 4x minus 3x. What is 4x minus 3x? That is going to be 1x equals, then I'm going to look at the other side. X minus 8, I can't do anything with that, so I'm just going to rewrite it as x minus 8. And then my next step is to draw my line down both sides, or I'm sorry, to label my sides. So I have x's on one side and my numbers on the other. Well, it looks like there's only one thing out of place because I have an x over here and my x's should all be on the left. So to get rid of that x, I'm going to minus x from both sides. And I get 0, because those cancel, and those cancel, equals -8. Well, that's also weird. So hold on. Let's talk about it. So the reason that we had these two problems, 5 and 6, was because they both gave us weird answers, and we need to talk about that. So all of our other problems that we had done before always had a simple thing. They had one solution. All of our other equations had always had one solution. For example, we worked the problem out and we got something like x equals 3. Whenever you get something like this, 0 equals 0, that is called something with infinite solutions. That is called infinite solutions, and it's also known as the identity. And what this means is that the equation is true no matter what. So when you solve it, you're going to end up with something like 0 equals 0. And I want you to go back and I want you to look at this step right here, this step that I have written in blue. We'll notice that both sides of the equation say 3x minus 6. 3x minus 6 is always going to equal 3x minus 6 because they're the same thing. So no matter what no matter what value x is, it's always going to work out to be true. Our third option is that they could have no solutions. And this equation, no matter what, is never true. And that's going to work out, and you're going to get something like 0 equals 2. Well, 0 and 2 are not equal, and that's why this gives us infinite solutions. So if we look at problem 6 over here, and look at this step. Well, this side says that you take x, and that's your answer. This side says you take the same x value and you subtract 8 from it. Well, if you have the two numbers and one time you're subtracting 8 and the other time you're not, then that final answer can never be the same. So that's why they have absolutely no solution, because no matter what, the left side will never equal the right side. Our instructions for 7 and 8 say to identify the number of solutions, so we've got to work these out. So we're going to go through the same process. We're going to draw our lines, and we're going to simplify each side. So to help us out, I'm going to cover up the right side so we can look at just the left for now. Well, I have parentheses here, so I know I need to distribute, so I'm going to rewrite my 5x, and then I have 2 times 5x, which is 10x, and 2 times 3 is 6. Equals, then I'm going to look at my left side there. I can't do, and my right side, I can't do anything to that. So it's just going to be 15x. So I'm going to continue my simplification because I notice I have a 5x and a plus 10x. So I can combine those together. So I end up with 15x plus 6 equals 15x. So I'm going to label my sides as my x's and my numbers. This time, I'm going to make my right side my x's and my left side everything else. And the reason I'm doing that is because on this right side over here, all I have is an x. So if I just move all my x's there, they'll all be in one place. So that tells me my 15x here is in the wrong place because it has an x with it, so it needs to be on this side. So I'm going to move that 15x by minusing both sides by 15x. And these cancel, and I'm left with 6 equals 0. Well, 6 cannot equal 0. This right here is not true. It's not correct. So that tells me that this has no solutions. That's what I know about this. Because 6 doesn't equal 0, there are no solutions. And you could also have looked at this step right here and seen that, because notice they both had 15x in them, but this side also had a plus 6. And that can't be true. You can't have 15x plus 6 equals just 15x. We're also going to solve problem 8 here, so I'm going to draw my line down the middle first. Then I need to simplify each side, so I need to distribute. I'm going to cover up this left side to help us out. And cover up the right side, I'm sorry. So I need to distribute. Negative 2 times 4y is negative 8y. And negative 2 times 1 is negative 2. And that equals, let's look at our right side now. I can't really do anything to the right side. It says negative 8y minus 2, so we're going to leave that the way it is. Well, if you look at this right now, the way it's set up, you should be able to figure out what's going to happen. So we're going to go ahead and continue our solving. So I'm going to label my sides, and this time I have y's, and then everything else. So that's what we're going to be solving for, is y's and everything else. What's on the wrong side? Well, this minus 2 here doesn't have a y with it, so I know that needs to go. So I am going to add 2 to both sides, because whatever I do to one side, I have to do to the other. So these minus 2 plus 2 cancel. So do those, so I end up with negative 8y equals negative 8y. Well, I'm still trying to figure out, get all the y's on one side, so I need to add 8y to both sides. And again, those are going to cancel, so I'm left with 0 equals 0. Since these two were the same right here, this tells me there is infinitely many solutions. What that means is that the left side and the right side are the same. Okay? Well, if you look at this, you can actually see that as well, because you can look right here and notice that both sides had negative 8y minus 2. So since the left side, negative 8y minus 2, and the right side, negative 8y minus 2 are the same, that tells us automatically there's infinitely many solutions. So we have 2 questions here at the bottom. It says the equation blank is never true, so the equation has blank solutions. Well, the one that was never true was equation 7, and it was never true, and that means it has no solutions. And the equation 8 was always true. Remember, it's always true if the left side equals the right side. Like, they are literally the exact same. And so that's going to have infinite solutions. The ones that are never true are the ones that are going to turn out weird, where it's going to look like this, where it's going to have something like 15x plus 6 equals 15x. I'm going to do another example, and this example is actually going to come from your homework. So I'm going to be doing problem 7 from your homework assignment. Problem 7 says 2/3 times 3x plus 9 equals negative 2 times 2x plus 6. And I picked this one on purpose because it does have that fraction in there, which tends to make things a little more complicated. Our process is still the same. We draw a line through the middle of our equation, and then we're going to look at our sides. So just to help us out, I'm going to cover up the right side so we can look at the left, and we're going to need to distribute because we see parentheses. So 2/3 times 3. If you don't know what that is, put it in your calculator. Don't try and figure it out on your own. It is 2x, and then 2/3 times 9. Again, if you don't know what that is, put it in your calculator. It actually works out to just be 6. So we end up with 2x plus 6. Then I'm going to cover up the left side, and we need to distribute again. Negative 2 times 2x is negative 4x, and negative 2 times 6 is negative 12. We cannot combine anything on either side, so we're going to go ahead and just move on to our solving. And for our solving, the first thing I'm going to do is I'm going to label my sides. I have my x's and I have everything else. So now we're going to start our solving. So what's out of place? This plus 6x is out of place, so we're going to minus 6 from both sides. And we're left with 2x, because plus 6 minus 6 cancel, equals negative 4x minus 18, because negative 12 minus 6 is minus 18. This minus 4x is also out of place. To get rid of that, I'm going to plus 4x to both sides. And 2x plus 4x is 6x equals negative 18. And for my final step, we haven't had to do this in a while in any of our problems. Remember, if a number and a letter are together, they are multiplied. There's a multiplication symbol in there. So to undo multiplication, I need to divide both sides. So I end up with x equals, well, negative 18 divided by 6 is negative 3. So that would be my final answer. X equals negative 3. I'm also going to do problem 13 on your homework. So problem 13 is on the back side, and our instructions are to determine if there is one solution, no solution, or infinitely many solutions. In order to figure that out, we actually have to graph it. We have to solve it. So 2 times 3x plus 6 equals 3 times 2x minus 6. So we're going to first draw a line through the middle. Then we need to simplify our sides. So to help us out, I'm going to cover up this left side for now. The right side, I'm sorry, and we're going to work with the left side. 2 times 3x is 6x, and 2 times 6 is 12. So my left side is 6x plus 12. And then if we look at our right side, well, 3 times 2x is also going to give us 6x, and 3 times negative 6 is going to give us negative 18. Again, some of you could probably look at this right now and tell me if it's going to have one solution, no solutions, or infinitely many solutions. But I'm going to continue to work out the problem. So we're going to solve this. So I need my x's on one side, and I need my numbers on the other, everything else on the other side. So what's out of place? Well, I got a couple things. First of all, the plus 12 is out of place right here, because it doesn't have an x with it, so I'm going to minus 12 from both sides. So that gives me 6x equals 6x minus 30. And then the other thing that's out of place is my 6x. So to get rid of that, I'm going to minus 6x from both sides. 6x minus 6x is going to give me 0. Those cancel. Oh, those cancel again, and I get negative 30. Anytime you end up with two numbers where these two numbers are not equal, that tells us that there is no solution. Okay? So to sum up everything, to solve, we do the opposite operation or the inverse operation. We learn that there are three types of solutions. There is one solution. You could have no solutions. Or you could have infinitely many solutions. When you end up with one solution, you work your problem out and you get something like x equals 4. With no solutions, when you work your problem out, you end up with something like 0 equals 12, so where the two sides are not equal. And for the infinitely many solutions, when you work your problem out, you get 0 equals 0. And what that means is that they are always equal.